Good evening, and on behalf of the institution and our 2022 President, Jane Entwistle, I'm very pleased to welcome you both here in the auditorium of the institution and online for the return of the institution's Maitland lecture, the first time we've held this event since moving to Bastwick Street in 2015. The lecture was introduced to mark the service of the institution's former secretary, Major R.F. Maitland, who was in post for a remarkable period of 31 years before retiring in 1961. The broad principle is for the institution to host a lecture on a topic of linked and general interest to structural engineers, rather than on a technical or engineering subject. Our most recent guest lectures have included Lord John Brown, the former Chief Executive of British Petroleum and President of the Royal Academy of Engineers, who spoke about collaboration between disciplines. Tony Little, headmaster of Eton College, who spoke about the shrinking curriculum and the importance of breadth in education. And Lord Digby Jones, a former Director General of the Confederation of British Industry, who subsequently served in Her Majesty's government as a Minister of State. He spoke on internationalism and the role and influence of the UK. The climate change emergency and how apt that the lecture is being held this week as new record temperatures have been recorded in the UK is a subject very much on the highest institution agenda. We recognise the immense responsibilities on structural engineers who together account for significant proportions of the world's embodied carbon in their designs. And it is our priority as an institution to provide guidance, tools and support in addressing a total change culture in the way structural engineers work. And this provides the linkage to this evening's Maitland lecture and parallels that we share with the agricultural sector, not only in matters of biodiversity, but in their quest to maximise yields, optimise crop selection, land usage, and to adapt to the changing weather cycles and extremes that are the product of our changing climate. Our guest lecturer this evening is Dr Alastair Leake, who heads the Allerton project, a 320-hectare demonstration farm based in Leicestershire. Alastair has spent many years developing holistic approaches to production that maximises yield and biodiversity, whilst minimising environmental impacts. He is a renowned speaker and translates the practicalities of farming right from his local area through to the policy-forming arena of Westminster. After the address, the President will proceed unannounced with the rest of this evening's formalities. Please welcome Alastair to the lectern. Alastair, thank you.
Martin, thank you very much for that introduction, and welcome, ladies and gentlemen. It's wonderful to see you here, and what a privilege to be invited actually to speak to an audience which I would not normally expect to find myself in front of. But what I'm going to talk about is important to all of us. And, you know, as Martin said, we couldn't have really picked a better time to be looking at this when we have a war in Ukraine where a large amount of our food supplies come from. We have a climate emergency which is resting itself on us at this very moment. And I've been privileged to spend 30 years of my career working on some of the solutions to what we're now facing within the agricultural sector. And I'm delighted to share with you my findings this evening. So the organisation I work for is a scientific-based charity, and half of our employees are postgraduate scientists. So we've been wrapped up in this. We're 75 years old, so we've been at it for quite some time. And perhaps different from many other conservation organisations, we work with the food production system and biodiversity simultaneously. A lot of other people try to separate the two, and I will go through why I think that's not the approach that we need to take. So this evening, I'm going to briefly look at the challenge of feeding a growing world population, how we're adapting farming systems to meet that challenge, and to reduce the impact of food production on the environment. And you'll probably know that farming is implicated in some of the greatest losses of biodiversity on the planet. So, this is an area where we can really make some progress. I'll give you some examples of the Allerton project, which is the 800-acre farm which I manage at the moment, and another site where we've been working for 50 years called the Sussex Study. I'll then go on to look at soil health, how we manage carbon and greenhouse gas emissions from land, and how we make better use of natural materials and waste agricultural products, which in fact are byproducts of food production, but can be used very effectively, not least actually in the construction trade. And finally, I'll reach a few conclusions. So this is what we're facing. In the last 50 years, our world population has gone from 4 billion to over 8 billion. And if you look back in history, that is the biggest impact that we've had on the planet that can be conceivable. We've managed to do this because we've managed to do two key things. The first is this: we learned how to manufacture nitrogen fertilizer through a chemical process rather than relying on biological fixation. And it's estimated that 40% of our global population now is effectively fed by manufactured nitrogen. The second thing we managed to do is to turn wild growing plants into productive crop plants. And you can see here a few examples of that. These are watermelon, maize, carrots, aubergine, and bananas. And on the left-hand side of the slide, you see the plant material that the breeders started with and what we've ended up with now. They're almost unrecognizable from each other. And such is the success. Put the plant breeding together with good crop nutrition, and then you have grown a whole load of calories to produce the food for that growing global population. And we're not immune from this just in this country. It's not just a global problem. In the last 10 years alone, we've gone from 56 million to 67 million people in this country. And when we look at this on a global basis, the amount of land available to grow food for each person has dropped from 2 acres to half an acre in the last 50 years and is still going down. This means we've been adding on average 210,000 people more each day to our global population. But more than that, 60% of all the people alive on the planet now live in cities and do not have the capacity to grow their own food. Here in the UK, we were very successful in the mid-80s at being self-sufficient in food, but we are now less than 60% self-sufficient in indigenous foods. And what we've managed to do in the past to plug this gap is to ever increase our yields per acre or per hectare to feed more and more people. But in the last 30 years, our ability to do that has tailed off. Increases in this case, wheat and barley, which are two products which we are self-sufficient in the UK, have really not increased in the last 20 to 30 years. And now we're struggling with climate change to get the yields that we would normally expect to get, even without developments in plant breeding. So if you look at the rate of increase through the 70s and 80s, you'll see that we have now tailed off, and our ability to be able to get more food from the same piece of land is diminished. There are some things which we now know we can do better. One of the things that we've not been good at is addressing our soil health. And this is something that even politicians have struggled with. At one point in the Agriculture Act, there was no mention of soil. This is the new post-Brexit Agriculture Act. That meant that with no soil mention in the Agriculture Act, getting public funding for improved soil health would not have been possible. And I was delighted to work with some colleagues to get a clause put in that now allows the government to pay farmers to adopt measures which improve soil health, which surely has to be right for our food security. So against this backdrop of increased food production through plant breeding and through fertilization, we also have the negative backdrop of what we've done to nature. These are UK bird populations, and you can see from the bottom line here that the suite of birds which is suffering the worst are those which inhabit our farmland. And that is because they are being squeezed out by our food production system. Now, some people's means of dealing with this is to create nature reserves. Now, nature reserves are fine in their own right, but given that 70% of our land is farmed and producing our food, we have limited space in which we can spare to make nature reserves from. And there are some people that advocate we go a step further, and you'll undoubtedly read about this in the press, wishing to rewild landscapes. Now, this is a possibility, particularly in the landscapes which are agriculturally unproductive. And one might argue this is a very good place to have your biodiversity. But as you can see from this picture, there's not much there for human beings to eat, unless perhaps you own a shotgun. So how are our farming systems adapting to deal with this need that we have to reduce our impact on the environment, but continue to produce plentiful quantities of quality, affordable food? And these are 5 farming systems which various people are adopting currently to meet those ends. And I'll go roughly through what each one means. So organic farming is really a very traditional approach where you use naturally occurring fertility through leguminous crops which naturally fix nitrogen to increase the productivity of the system. No artificial fertilizers or pesticides are allowed, but it does bother me that you can spray organic potatoes with copper sulfate because that is a natural product. But this system is typically 40% less productive than what 97% of farms in this country are doing, which is conventional farming. Now, conventional farming is what is feeding us, but it is energy intensive and it is ecologically damaging. And the result is, without surprise perhaps, we've come up with a hybrid which brings in the best of what organic farming systems deliver in terms of natural pest and weed disease control, natural fertility building, but using chemicals in a very measured way within the system. This approach also moves away from intensive tillage, which I'll talk a bit about shortly. Some of you may also have come across this phrase, conservation agriculture. This globally is very popular, particularly in countries where you have dry conditions. And it consists of minimizing soil disturbance, which is important because when you disturb soil, you lose the moisture from it. It consists of permanent soil cover, which helps to keep the moisture within the soil. And it relies on species diversity within the crop rotation to create biological diversity within the farming system. These 3 pillars then are supposed to support these ecosystem services, as we call them, that go ahead. And finally, very popular in the last 5 years or so is this concept of regenerative agriculture. This is actually organic farming with chemicals. Okay, so that's basically what it is. It's turning the clock back to bringing livestock back into the system and using grass and clover lays. So let me take you now to the first of the case studies, which is my own farm, the Allerton project on the Leicestershire-Rutland border. We're 800 acres. We're on pretty challenging soil. It's a grade 3 clay soil, which makes it hard to grow arable crops on. And we set out an objective 30 years ago to combine productive farming with wildlife conservation, with the objective of increasing food production and biodiversity simultaneously. We were very privileged to be left the estate by the late Lord and Lady Allerton, and there's an aerial view of the countryside of East Leicestershire and the village of Loddington, around which this is based. And here is a map of the farm showing some of the crops that we grow and some of the fields that we have to experiment with. So this is the backdrop against which we started this work, which is this decline in songbirds that we've seen since we started counting birds in the mid-1960s. So this perpetual decline that we see really right the way up until the mid-1990s in our songbird numbers. And what I've done here, this is our national picture of songbirds. I've then put against that the national picture of wheat yields, which show this steep increase from the 60s up to the 90s and the levelling off that I talked about before. Now, we knew from estates which managed game that if you wanted to shoot pheasants or partridges, then you needed to improve habitat, winter feeding, and predation control. And that worked for game species. The question was, would it work for songbirds as well? So in 1993, after a baseline year of recording, we began to make changes to the farm, and the response was dramatic and rapid. The 30-year decline that we'd seen in songbirds was reversed in just 3 years. Now, that's extraordinary to me, because I'd always been told that that 30-year decline would take 30 years to recover. But in fact, if you do the right things, you can get that back very rapidly. And you can see that then we maintained that doubling of our songbird numbers right the way through to 2002. And perhaps even more extraordinary, when I looked at our wheat yields on the farm, I found that in most years, in fact, 5 out of the 7, our farm was actually producing more wheat than was being produced nationally. In other words, arguably, we were more intensive than the average farm. So there you have something that I was told was impossible. High levels of biodiversity and high levels of productivity on the same piece of land. What we've seen previously is one taking advantage of the other. And how have we done that? We did it by taking the least productive land out of production and repurposing it into wildlife habitat and then managing that habitat very well. But those of you who are not yet already asleep will notice that my figures stopped 20 years ago in 2002. And there's a very good reason for that. Because at this point in our journey, people are saying to us, this is an extraordinary achievement. But what do you think has contributed the most to that outcome? Is it the predation control? Is it the winter feeding? Or is it the habitat manipulation? And the only way you can test that is to deconstruct what you're doing. We call it the three-legged stool. And what you do is you chop a leg off at a time and see what happens to the stool. So the first thing we did was stop the predator control. Now, when I'm talking about predator control, I'm referring to the control, the legal and humane control of foxes, corvids, magpies, crows, rats, grey squirrels, okay? And this is only done during the nesting season to protect breeding bird species. So it is a very targeted approach. But you can see the removal of predator control did instantly have an impact. The next thing we did was cut the other leg of the stool off by stopping feeding them in wintertime. And at that point, we almost returned back to where we began. And there is a very salutary lesson, because that tells us that habitat management alone is not enough. You need to have management in the system as well. And from 2010, we brought back the original system, but in a slightly different guise, which I won't go into the full detail of. But we increased the amount of land that we were managing and reduce the amount of time the individual we employed, the wildlife warden, was engaged. And yet still, we are sitting today at 93% above where we were when we started this way back in 1992 with the baseline. So let's drill down into how we've done some of this. Use less productive land for wildlife. Well, how do you determine what less productive land is? Well, the great thing now is our modern combines can yield map as they go around the field. So they can tell us where the poorer areas are. And what we find consistently is up against the field margins, there is a depression in yield. So we can take out this 5 meters at the side of the crop and we can repurpose it into habitat. And because we knew that food was short for birds in wintertime, we devised a whole load of seed mixes like this, which can feed birds through winter. So along the top here, you have a list of plants which produce seed, and down the left-hand side, you have a list of birds that eat that seed. When we know which birds eat what seed, we can design a mix to go in the least productive part of the field to feed the birds during the winter time naturally. And as you can see from this, a mixture of kale and, well, what we farmers would call quinoa, but I believe if you go into a health food shop in West London, you probably should say quinoa, mixed with some millet, will provide fantastic food for birds during the winter time. We also learned that just plonking them in the ground was not good enough, and that just as we manage the crops in the middle of the field professionally to produce a high yield, so we have to produce the strips at the side of the field professionally to produce a high yield to feed the birds. In fact, a little bit of fertilizer, just 60 kilos per hectare, and bear in mind a crop of potatoes would need 300, just 60 kilos of nitrogen per hectare gives a 10-fold increase in the amount of bird food to feed birds in the wintertime. So here's a very typical strip of the Allerton project. You've got a well-managed hedge, a tussocky field margin, and then you have the wildlife seed mix, and then some oilseed rape, which is the commercial crop, which the farmer makes his money from. But unfortunately, this is still not the end of the story. Because what we found was that when we doubled our songbird numbers, they doubled the rate that they ate the seed. And we couldn't produce enough to feed them. You can see here plots of millet, 60,000 seeds per square metre. And what happens here through September through to January is the yellowhammers, which are marked in the blue line here, are coming in and feeding that, such that when we get to January, there's no seed left. And the problem with that is that they need to make it through to March and April before there'll be any fresh seed shed in the countryside for them to feed from. And I guess it's a bit like what we all do, or many of us do in our gardens, which is that we feed the birds during winter time. So we started to do that, but we did it in a scientific way, and we put a CCTV camera onto each one of these hoppers so that we could record which birds came in to feed and when. And here you can see some yellowhammers coming in February because they've run out of food on the rest of the farm and they've come into the feed hopper to get fed. The other problem is, of course, that you don't just feed the things that you want to feed, you feed the other things that want to come out and enjoy it as well. And that's why you need to have a bit of predator control going on, because somebody needs to control those, otherwise they'll become a problem within the system. But from gathering a whole load of data over a number of years, we were able to ascertain about half the food that was being put into our hoppers was being fed to small birds, and that was playing a big part in the doubling of their numbers. We also found that the more birds, and this should be no surprise, but it's nice to scientifically measure it, the more birds you've got that survive to the late winter, the more breeding pairs you have the following spring that go on to increase your population. But if you stop feeding, then you literally halve your population. So by providing food in the wintertime, either through seed mixes or through hoppers, we've been able to double our songbird numbers. But it's still not the end of the story, because we have another pinch point besides winter food, which is the provision of insects in the summertime. So we've been designing designer seed mixes, which provide pollen and nectar mix. We've got 50 years of research on this particular species, the grey partridge. And what we found with grey partridges is that 95% of their diet in the first week was insect. And even into the second week, 80% of the diet is insects. And by sampling fields for over 50 years, we've produced this direct correlation, which shows how many more chicks survive, the more insects there are present. And that is why keeping insects on the farm and in the environment is absolutely critical, and why we have moved away from using any insecticides at all on the farm, relying on enhancing biological control instead. Now, it's very nice for us to have managed to do this on our heavy clay soils in the English Midlands, but then somebody volunteered to have a go at the three-legged stool in the south of England, here in Sussex, on a chalky downland soil, which is very different to the environment that I'm in. And here you can see a few tiny red splodges, which are the very last few grey partridges which are left in this landscape. They are almost extinct. And this is the study area that we went into. We put the three-legged stool philosophy into place, and by 2010, we had record numbers of grey partridge on this farm. So, ladies and gentlemen, I think we know what we can do to reverse farmland bird decline. And if we implement those professionally and we incentivize by government to do so, then I believe that we can reverse those declines that I showed you. Now, people do want to know, is the impact of predation important? And yes, to some degree it is, but it does go rather species by species. Our fox population has been ever increasing. Our magpie population is 3 times what it was in the 1960s, before we saw the big collapse in songbird numbers. And the crow population is also about double what it was. And certain species, what we call the open cup nesters, blackbirds, song thrushes, chaffinches, yellowhammers, are particularly affected by corvid predation. And just to look at some of the science which we've published behind this, it's quite extraordinary the increases in these 4 species that we've been able to show by limiting the number of magpies and crows. Other species, such as skylarks, are completely unaffected by any sort of predation control. And the other species which has done extraordinarily well out of us controlling foxes is the brown hare. The brown hare population absolutely exploded until we stopped controlling foxes, which was here in 2001. And so you can see that this dropped away until we started controlling foxes again. And even now, the return has not been as spectacular as we got in the first instance. And neither has our recovery of wild pheasants. And this is because we now have a very large badger population on the farm, and anything which nests on the ground is struggling to raise young. So I want to move on now to talk a little bit about soil health and the importance of that for us being able to feed ourselves going forward. When I see satellite images like this, I get greatly concerned. This is after a big rainfall event, and this is our agricultural soils being washed away. Our soils have become degraded by erosion and by intensive agriculture, despite the fact that soils are home to a quarter of the living species on Earth. And 1 hectare of soil has 5 tons of living biomass within it, if it is a healthy soil. The problem is, as our machines have got heavier and bigger and our fields have got larger, we have started to cause this. And as a room full of structural engineers, let me just tell you that soil structure engineering is as important to me as an agriculturalist as building construction should be to you. This is a field which has lost its loose soil to erosion, and all is left is the soil which was compacted. The farmer did not know that his field was even compacted until he lost the loose soil. He did know that his crop yields had dropped, but he didn't know why until this happened. And when we look at our soil structures, what we want to see is what we've got on the left, which is a nice, loose, good structure which roots can get down into the subsoil to get nutrients and moisture, rather than here where you've got this ceiling which is going to prevent roots from getting down into the soil. When we see this compaction, we can see that not only does it make it difficult for plants to grow, but it also makes them less resilient to drought because they can't access moisture deep in the soil. On one of our fields where we've stopped ploughing, we've seen the earthworm numbers go from 200 per square metre to 700 per square metre in a period of 10 years. And when we dig down into the soil, we can see that where we've stopped ploughing, we have a large number of large holes which the earthworms are making. And that when it rains, the water soaks into this soil a great deal better than it does where we've ploughed. And that means that when we go through a drought, which we're currently doing at the moment, it's interesting to note that the field with the most earthworm is the one that's looking the healthiest, because the plants are using the earthworm burrows to extract the moisture. And if we look at that in terms of measuring that airspace which is created by the worms, you can see the huge difference between those 3 tillage systems. And when we look at what happens when it rains very hard and we're getting more and more of these sort of events, we get more runoff washing our soil off than we do under a modified system where the water is infiltrating the soil far better. So this age-old method of seedbed preparation is now giving way to this modern system whereby we simply slop the soil, the seed straight into the soil using a low disturbance machine, which means that we don't have to move the soil around. Takes a bit of getting used to, because you're going to see trash lying on the surface of the soil for a lot of the time, and it looks very untidy. But we're now discovering there is a big advantage to this waste matter lying on the surface. This next slide shows the infection of a plot of wheat that has been ploughed with barley yellow dwarf virus, which is spread by green fly, which fly into the crop and transmit the virus. Immediately next to it, you can see a zero-till plot with no infection of barley yellow dwarf virus. Now, this is important because what this is showing us is that this new untidy system is very good for beneficial predatory invertebrates, and they are eating our pest species because we're creating a better environment for them to survive. And there's no crop that this has become more important in than something called oilseed rape, where you can see the amount of UK production of oilseed rape has crashed in the last 7 years or so. It's collapsed because we're not allowed to use this seed dressing, which I show you here. This is an insecticidal seed dressing, which is applied to the seed pre-planting. When the plant germinates, as you can see, this one I've dug up has, this coating on the seed coat provides insecticidal protection to that seedling so that it can grow on and grow a healthy crop. The problem with us not growing oilseed rape in this country to the same degree anymore is that 80% of our vegetable oils, sunflower oil in particular, come from Ukraine. And if it doesn't come from Ukraine, it'll be palm oil, which comes from Indonesia, where it's come from cleared rainforest. So finding a way to grow oilseed rape in this country without using chemicals, but by using natural control, is something we've been working on. And we found by simply leaving a long stubble, in other words, raising the cutter bar on the combine high when we go through to harvest, and leaving a long stubble allows spiders to spin their webs, and they then catch the pests coming in to infect the oilseed rape. So this is something that we've got to do more work on, because although it's worked in several years, one year the spiders didn't turn up for work. And that means that we have a pest problem, which we have to deal with. So let me now move on to the last part of my talk, which is to look at how we deal with getting to net zero and what we can do as farmers and land managers better. Better use of fertilizer, reducing, improving the way we manage our vegetation, better soil management, restorative rotation, and the use of agricultural byproducts. And this is the issue that we face. The three main gases which come from farming are carbon dioxide, methane, and nitrous oxide. These are the global levels that we see going up. Yet, reassuringly, one of the great solutions to taking carbon dioxide out of the atmosphere is actually through farming, because we work with both soils and plants. And if you look at global CO2 levels, you normally get shown a straight line. It's not actually a straight line, because every time the Northern Hemisphere comes around into summer, plants suck CO2 out of the atmosphere and we get a dip, but then it goes back up again. So on the farm, what we're trying to do is develop ways of calculating the amount of carbon that we emit and how much we can lock up in what I call the ecological infrastructure of the farm. We are inundated with different calculators, all of which have their strengths and weaknesses. So the farmer can use these to work out how much CO2 is being emitted through growing a ton of wheat or producing a litre of milk. But we know the main things which are responsible are nitrogen fertilizer and our cultivations and harvesting operations. These are what are fueling the carbon emissions from the farming system. The good news is that we've now learned how to extract hydrogen from water using renewable energy rather than taking it from natural gas, and we can produce green ammonia, but there's still a great more that we can do. You can see from this graph that 50% of the nitrogen, this is a nitrogen response curve, so 200 kilos of nitrogen gives us our maximum yield, but actually 50% of that 200 gives us about 80 to 90% of the total yield. In other words, this area here, we are relatively inefficient in the way we're using that nitrogen fertilizer. We could cut 20% of the carbon footprint of a ton of wheat quite simply by working there, or working in this section here where we increase the amount that we get naturally from the soil. That would have a big impact on what we can achieve through reducing our emissions. Nitrogen fertilizer emissions, or any sort of nitrate leaving the system, causes ecological problems within our aquatic systems. And the good news is that some of our modern breads that we make need lower levels of nitrogen in the flour to make them effective. And in fact, all the good work that I might do to reduce the carbon footprint of a loaf of bread, which we've managed to do by about 30%, can be undone by you straight away by putting the bread in the toaster. And let's also have a look at some carbon management in the uplands. There's a lot of debate about cool burning, burning excessive vegetation during the winter months to create a mosaic of habitat and to try and prevent wildfire fires. And you know, what a week again for us to be talking about this after what happened yesterday. But what happened yesterday is not uncommon in the uplands. Back in 2018, this was Saddleworth Moor, because we had decided that it was a bad idea for global warming to cool burn heather in wintertime. So we were left with a huge fuel load on the surface, which went up uncontrollably, and this could not be managed. The problem with this is it also burnt 200 years worth of peat. Carbon stored in peat went up in that fire at the same time. So there is a lot to be said for managed burning. And if you look at Australia or the United States of America, they have learned to do this already and still get into trouble. We need to start looking at this more carefully. The other major issue for us in this country and a society generally is that 70% of our carbon emissions coming from land use are coming from our grade 1 peat soils. These are the soils that are feeding us most of our vegetables, which come from the fens. And this is not a new phenomenon. When we drained the fens 200 years ago, people put markers in as to how deep the peat was. And you can see that this is not a new photograph. So even in the early stages, we've seen large emissions of carbon coming from those soils, which I'm afraid are continuing to this day. I was in the fens last Friday. They were desperately harvesting lettuce because everybody wanted lettuce for the heat wave. But this is what it means. It means that we are growing crops perpetually on the same soil and degrading them whilst emitting carbon dioxide. And what we need to do is to go back to an age-old system of rotating restorative crops with exploitative crops, which build our soil carbon up. And there's no better way to build soil carbon than to introduce grass clover leys back into the rotation. That will be the immediate solution to doing it. The second thing we need to do is to move away from ploughing, which burns carbon as it does it. And we're lucky enough to own a portable gas analyzer, so we can go into the field after we've cultivated it and measure the amount of carbon dioxide coming out of that soil. And what we find quite clearly is the greater the soil disturbance, the more carbon dioxide. However, that is not the whole story. In compacted soils, and I showed you examples of compacted soils earlier, we get more nitrous oxide emissions. And nitrous oxide is 300 times more potent than carbon dioxide. So we need to fully understand what we're doing in order to make the right decisions. When we put the two together, we find that the undisturbed compacted soil is as bad as the ploughed soil. But if we reduce the compaction here, using something called a low disturbance subsoiler, we would achieve the best of both worlds. And so finally, and because I'm here in front of my esteemed audience of structural engineers, I'd like to show you a little crossover between what we do on the farm and what you can do with buildings. And this is our new visitor centre. Well, I say it's new, it's 10 years old. And I'm deeply indebted to a structural engineer from Pick Everard in Leicester, who came out and declared this cattle shed of mine as being suitable to refurbish and turn into a new visitor centre without demolishing it. And I didn't wish to demolish it because there's a lot of carbon already been invested in those bricks. So if we can use it again, then we should. And I'm delighted to say that this building went on to win two awards. So this happened yesterday, but 20 years ago, we used to do this deliberately. This was our way of clearing the fields before sowing our next crops, when in fact, this is what we should have been doing, making straw bales out of it. So we sold the wheat to Kellogg's to make Special K, baled up the straw and created insulation for the building. using 8 times less carbon than you would if you made rock wool, and giving double the insulation spec to the building compared to man-made fibres. This is us restoring a hedge. Coppicing it is called, and this is what we used to do with the material that we coppiced from the hedge. When in fact what we should do is put it through a chipper, put it into one of our grain trailers, which we have on the farm anyway. So the chipper is simply acting as a combine harvester, filling the grain trailer with wood chip. We take it down to the grain store in July. Grain store floors are vented with air to keep the grain dry. We use 128 solar panels on the roof to provide the electricity to do that. That dries the wood chip. That keeps all our offices and all our visitor centre heated using our own biomass now across the whole premises. We have the funding to generate a hedgerow carbon code at the moment. This is going to allow farmers to put in the length, the width and the height of their hedges and work out how much carbon is in it. So instead of just being good for biodiversity, we can now make it good for carbon as well. And we're also starting to use waste products in our material. Silage wrap is one of the most difficult things to get rid of, but you can turn it into a car park. And because it's permeable, you can sow it with wild flowers so that it's not just concrete or tarmac, but you drive on it and it's good for pollinators at the same time. And finally, you know, our ability to be able to make laminates from Sitka spruce, which is not good for the environment, but once again, just as growing a crop of monoculture wheat is not good for the environment, we need to know how to grow Sitka spruce better for a construction material if we want to replace concrete and steel. And here's the office block that we've just built. It's not yet inhabited, but this is pretty much 100% timber, except a few screws to hold it together. So, ladies and gentlemen, thank you for your attention. Just some conclusions of what I've gone through. There's no doubt human population growth has negatively affected Earth's natural ecosystems. And modern farming needs to adapt to reduce this impact and deliver other non-food services. I firmly believe that if we increase the crop output from the productive land and increase the wildlife on the unproductive land, we can achieve this utopia of feeding a world-growing population and protect our biodiversity. The professionalism in which we care for wildlife needs to be as smart as the professional is for growing our crop. But our soil health has been neglected, and we do this at our peril for feeding ourselves in the future. But as a farmer, I'm extremely privileged that plants in the soil have a huge capacity to lock up carbon, and I really just got to learn how to do it better. Thank you.
Right, so we've got some time for some questions now. And what we're going to do is first of all take questions from in the room, and then we'll follow through with any which have come in online. So does anybody here have any starting questions? Yes. So if you can wait for the microphone before asking, thank you.
Thank you very much. It was a really interesting talk there, Alastair. You spoke about obviously, moving away from using, lots of fertilizers and things like that, nitrogen and insecticides. Where about herbicides in a sense? I mean, they're a sort of bogeyman for some people, but they obviously have a huge use and a purpose, particularly with sort of, persistent weeds like blackgrass and things like that.
Yeah, so the whole approach to improving our soil carbon levels and managing our blackgrass is actually through the rotation. And it's our abandonment of these rotations which alternate exploitative phases with restorative phases that has been our downfall. The interesting thing is that if you're building fertility using legumes to fix your nitrogen, you're also fixing your carbon at the same time. The two are tied together. And so we're finding that we're now able to manage our soils much better because we've extended the rotation. But, and there is a but here, We can only do it because we're using public money through the Environmental Stewardship Scheme to grow field-scale pollen and nectar mixes, which were paid £560 a hectare to grow. Now, this is grown to help bees and butterflies and pollinating insects, but it's also doing a great deal for the soil. And we seriously need a post-Brexit support system for farmers which pays them to deliver the environmental goods alongside restoring soil health and producing food for all of us.
As an industry, we're going down a similar road of trying to combat climate change. Are there any lessons in getting widespread change within the industry that you can give us of how you've handled that?
I wish there were. I'll give you one that I wish we'd been able to achieve a long time ago. We've always known that nitrogen fertilizer has been used less efficiently than it could have been used. And I showed you the big carbon footprint that is, and also the ecological impacts of it. But there has always been an approach that, well, it's quite cheap. You get a fantastic response for putting it on. So if a little bit is good, then more is better. Then you go to Denmark. Denmark put a ceiling on the amount of nitrogen fertilizer which their farmers were allowed to use. Within 5 years, they'd gone from being 60% nitrogen efficient to being 80% nitrogen efficient. Now, that's a lesson that I wish we could have learned. Funny enough, we are going to learn it now because fertilizer prices have gone from £250 to £300 a tonne to £800 a tonne. And all of a sudden, it is cost effective to use that nitrogen more efficiently. Perhaps previously we could have taxed nitrogen fertilizer to have achieved that outcome, but government was always reluctant to do that. This, in effect, is a fossil fuel tax that's now come in because the market has determined it. Yeah.
Hello. The slide you had where they had the rutting in the field. What was the causation for all the loose soil going, and what was the remediation works done on that? And a second question, you had a slide about the CO2 increase, and you had like a blue zone on the left-hand side, and it went up to a red zone. What level of CO2 are we at now, and what should we be at? Sorry for the two.
Yes, okay. So the second question first, we're 400 and something parts per billion now, and we used to be about 300 and something. So that's been a considerable increase. And the more it goes up, the more we suffer from the issue of climate change. Sorry, first question? Yes, the ruts, the compaction. Yeah, so, okay, so the farmer had clearly run all over that field, doing different operations. It looked to me like he'd been harvesting crop on another field and driven across it as well. So he didn't know the compaction was there. Then it rained heavily one night, and because the water couldn't get into the soil, it washed away the soil that was left loose. And so then he was able to see the compaction that he'd caused behind. Now, one might say, well, he should have run over the whole lot, and then none of it would have washed off. But actually, none of it should have washed off because the water should have been able to infiltrate the soil. And on a flat field like that in particular, I've got some sloping land, and that is a bit more challenging to manage. But on a flat field like that, it should not have presented a soil erosion problem.
Question at the front here.
I was just wondering, what was the reason that the sort of traditional methods of rotation were omitted in the first place in sort of intensive farming?
Quite simply because traditionally you couldn't have sustained a constant sequence of crops that did not restore the soil health. What conventional farmers are doing is they're replacing that natural soil health with fertilizer. So that allows them to continually grow exploitative crops.
You mentioned the importance of sinks in absorbing CO2, which is released every year, and the CO2 increasing, which my understanding is that it's the difference between two very large numbers. And if you don't manage the land effectively, we can end in a situation where the CO2 net increase each year continues to accelerate. So if we end up with more forest fires, the oceans warming and so on, we could reach the tipping point. What's your view about the importance of land management, effective land management, to avoid reaching that tipping point?
We're in a very fortunate position that because we've depleted soil carbon for a couple of centuries now, we have the capacity to replenish it. But there is a problem because it's not a tipping point, but it's what we call an equilibrium. We get to the point where you cannot stuff any more carbon into the soil because it's being emitted as fast as you're putting it back in. And it's just like a hedgerow. So I mentioned I'm doing the hedgerow carbon code. There's only so much carbon that hedgerow will contain, and eventually it's effectively saturated. Yeah.
When you talk about the compressed soil, how do you rectify that? Do you have to leave it and let the worms do their job, or do you have to very deeply plough it and then leave it?
It's an absolutely brilliant question, sir. What we have to use is what we call a low disturbance subsoiler, which is like a leg, a narrow leg that we pull behind the tractor, and it breaks the compaction up without heaving the soil up. And interestingly, when we go away from ploughing, we do start to suffer compaction. And actually, before the earthworms can get on top of that compaction problem, we need to give them a break too. So we have to go through with the low disturbance subsoiler, and they actually like that because it allows them to move around through the soil more effectively and increase their numbers. And after that, they should be able to take charge of the system. But we have to give them a helping hand. And it's kind of counterintuitive because anytime you pull a piece of steel through the soil, you think about the soft body of an earthworm, the consequences don't bear thinking about. But luckily, we've got scientists that measure earthworms, and they're able to say that the impact is not significant of doing that.
I was brought up on a small farm in North Devon, 21 acres, 6 fields. 2 were fallow, the rest were barley, potatoes, and some winter crops like mango for feeding. Now, we used to plough, but for the barley, but then there was a clover mix added to it, so that grew in winter. Now, there was, and the hedges were North Devon hedges, which were earth with the timber laid, the trees laid down on top. Now, fertilizer we didn't used to use, but because the soil was a very heavy clay soil, my dad used to use a basic slag on the land, which I don't think anybody uses these days. And although ploughing was done, there was lots of earthworms because the seagulls used to follow the tractor. So, you know, I don't know how you think. So that was in '66, but then there was the big farmers opposite didn't operate like that. Used lots of nitrogen fertilizer. So there's a kind of strange anomaly there, I think, really.
Not particularly, because if you were ploughing in the 1960s, you were probably ploughing 4 to 6 inches.
Yeah, it wasn't deep ploughing.
Well, these guys with those big tractors, they can't even feel it, you know?
Oh, see, right.
Yeah, and they're ploughing much deeper, and that means they're bringing up the earthworms from down below and depleting them. You were leaving a nice reservoir of wise ones that were deep down, and because they were wiser, they were probably older and bigger, and more likely to breed.
Right. So what about basic slag? What was it's never used now, is it?
No, well, it was a byproduct of the steel industry, you see, and without the steel industry, we lost the fertilizer.
Right.
Yeah.
Thank you. Alastair, as more and more organisations are trying to tackle their own carbon footprint, what's the agriculturalist view on these myriad of carbon offset projects that are calling for planting trees and all sorts of other things? Greenwash or positive benefit?
Okay, so I'm working with two big companies, Nestle in the milk supply chain in the Lake District. This is the milk that goes into the 8 million Kit Kat bars that come out of York every day. And I'm working with Kellogg's in Northamptonshire. This is the 100,000 tons of English wheat which goes into Special K. And what we're trying to talk to the farmers about is not offsetting, but insetting. So when I sell a ton of wheat to Kellogg's to make Special K, we also sell them the carbon credits for cooking that Special K that have been earned on the farm alongside the grain. Kellogg's are working on reducing the emissions from their part of the job by introducing hydrogen into the cooking process. So we're all working together. But what I want to do is to be able to sell my agricultural produce connected to my carbon credits. Yeah. That then ties my customer in so that they can't go off and buy some cheap Australian grain that has been signed away on a Liz Truss trade deal, which will undercut my grain. Yeah. And all the major food companies have commitments to achieve net zero. And the only way they're going to do it is to work with their supply chains. So I'm encouraging farmers not to go and trade their carbon now and sell it to somebody who might give them something for allowing somebody to fly British Airways to South America, but to hang on to it and use it as an asset alongside what they're producing in terms of food.
Thank you for a fascinating talk. The 5-meter strip around the fields, you said it was low yield. I'm just wondering on the mechanism for that, and if you've then pushed it further into the field, and if we're forever chasing our tail on that.
Are you a farmer by any chance?
A structural engineer.
Yeah, because that's what farmers always ask me. You know, eventually will I reach the middle of the field? You know. Yeah. No. Well, it depends on your field margin. That's the truth. Some of that yield loss is caused by turning in that area because we reach the end of the field. And so you are going to move some of that yield reduction into the next part of the field because you will continue to turn. But most of our fields are bounded by hedges. And hedges shade the crop, they take moisture out of the crop, and they basically deplete the yield. It depends on the crop, and it depends on the orientation and the height of the hedge, actually. Amazingly, sugar beet is very little affected by the hedge and will yield quite high up to the edge of the field. But wheat, you can go out 20 meters and still see an edge effect coming from the hedge. But yeah. It is a variable thing, but you will get slowly better the further out you go.
Thank you. The questions come in from James Darcy Parsons, who says, what simple things can we do in our gardens? For example, how we dig our borders or vegetable patches. And I'll just add to that, does no dig gardening work?
Listen, the best way you can do no-dig gardening is to use a fork rather than a spade, and to use the fork to loosen the soil, as I use my low-disturbance subsoiler, and build the earthworm numbers up. Put your well-rotted compost on the surface of the soil and let the earthworms do the work for you. That's my advice.
Thank you. Do you have another one in the room? Then we've got another online question. Yep.
It was just a follow up to the question that was asked earlier about offsetting. I mean, I personally generally think offsetting is largely a sort of farce, but you did mention that you get money to grow, for example, wildflowers and sort of the funding from the government. And I would wonder if some sort of carbon tax could be used for companies that wish to quote unquote offset, but it's funneled into those sort of ventures that are already being paid for, presumably through some government funding.
Yeah, it's a really good question. So the government are launching a new environmental land management scheme, and they're going to pay farmers to do things like pollen and nectar mixes. I may then choose to do some biodiversity trades on that, and then I might also look at the carbon, which is not included. No, you won't be at all surprised to learn that the Treasury is very interested in farmers that might be doing what we call stacking payments, because actually what they want to make sure is that there's no double funding. And I think there is a case here, actually, because what the public funding should do is to fill a market gap. And there is a market gap at the moment for funding biodiversity. So it's completely legitimate for public money to be used to improve biodiversity. But if private money then comes along and starts to replace that, then it is probably legitimate for the Treasury to look at what they're giving and saying, well, this is no longer a market failure. The market is working, farmers are trading biodiversity, they're trading carbon. But we're telling the government, don't do that at this point, because everybody will say, oh, I'm not going into the scheme because that'll stop me trading anything in the future. Or if I do, Treasury try and claw it back from me.
Thank you. We're beginning to run short on time. I see there's a gentleman over here has got a question. Somebody, no, yours is gone. One more at the front and then one more online. So if we can try and keep the questions fairly tight, please.
I'm very much concerned about the large frame. Our wonderful island represents something like 1% of humanity. We have the Secretary General of the United Nations suggesting that on Monday we're on course for collective suicide. This is fairly dramatic stuff. But I don't think our political messaging is sufficient for the need. I think we all need to understand that we need to stop many of the things that we regard as normal now and change the direction in which we live our lives. On the farming side, it's been made very clear that livestock farming is disproportionately environmentally damaging, I believe. Again, you haven't touched on that, but clearly, if we're trying to save the planet, and the situation is no less dramatic than that, we need to start thinking a lot harder about what we're doing and how we do it. I've made personal small changes to my lifestyle. I used to hot shower every day. I don't now. I do a basin wash. In the winter, you may have noticed it's cold. We do not need to heat the inside of our houses so that they are maintained at a comfortable tropical environment. We used to wear clothes in the winter as the best means of keeping warm. We need to think hard about that. Do you have any comments on this much larger frame of a world which is actually systematically destroying itself?
Not in the time we've got. But I might just make a quick comment about livestock. There are two forms of livestock. One is an intensive one, which produces a lot of emissions. And one is one which uses extensive pasture land, which locks up huge amounts of carbon, giving out very little emission. And if we were to lose the livestock from our extensive pastures and they were to be cultivated, the net impact on carbon loss would be massive.
Thank you. And last question in the room from the lady down here at the front.
Hopefully a quick question, but apart from, I'm assuming that money is one of the barriers, what are the main barriers that stop people adopting these techniques if they are so wonderful?
Average age of a UK farmer is 60. And it's even quite difficult for younger people coming in who want to do the new ideas because dad or mum say, this is how we do it. It's a real problem. Go on. Just from my own experience, yeah.
An interesting parallel there with older engineers saying this is how we do it. We need to listen to the youngsters. I said we'd cover the last online question, even though that would have been a really great closing line there. Lorna Ann Baker has asked, what would you consider the best use of public money for farmers to nudge the farming towards what we need? So what would the top things be to campaign for? And would it vary from lowland to upland farming?
Well, yes, it would vary from lowland to upland farming, but if we were to take 12% of our unproductive land out of production and repurpose it with public money into carbon, biodiversity, water quality, soil health, that would be a fantastic start.
Thank you. Well, it's been really fascinating listening to Alastair this evening. And in the same way that we were probably an unexpected audience, I think many people here would think that he would be an unexpected speaker. But you can see that there really are the parallels, the way we need to think more widely about what we're doing. So thank you very much. It's been really fascinating. There are quite a few things I've jotted down, which I'll have a think about and may even be in touch in due course. I thought can't read my notes all the way down now. The habitat maintenance and your three-legged stool I thought was extremely interesting, to the way you actually found out what the key factors were. And you know, there can be things that I'm sure we can draw as parallels. And I think one of the most shocking things actually was that the satellite photograph showing the washout. We don't often see pictures like that, or if we do, they perhaps don't normally speak to us in the same way. So we need that sort of publicity and people to tell us what we should be surprised at. And the idea that we're not allowed to toast our bread. Do you know, that's a real shame, but now that you say it, it makes some sense. If you've gone to all that sense to reduce the carbon footprint of a loaf by 30%, that's amazing to be able to achieve that by how the wheat is fed. And I must admit, I'd never actually thought about the need to think of the carbon footprint of the actual wheat itself in terms of whilst it was growing. So I'm sure there's been many eye-openers to many of us here this evening. And what I'd like to do next is to present you with a certificate, which, excuse me, walking behind you here. We have a certificate for the Maitland lecture as to thank Alastair as our speaker. We'll get some proper photographs later on, but thank you very much. Just finally, in addition to the certificate, there's also a cheque which goes to Alastair's chosen charity, which is the Allerton Research and Education Trust. So that will be given to you as well. We've got it over here for you. So again, thank you very much for the evening. And if people would like to move upstairs, I'm sure you might be able to get a few extra questions in on a one-to-one basis or in small groups over some drinks and canapes up in the upstairs area. Thank you very much.